participated in our previous video. In this lecture, okay, great. Now that we know more about the dashboard, we are ready to examine the shell and see how we can code in Jupyter. The field you see here is called a cell. You can access a cell by pressing Enter. Once you've done that, you'll be able to see the cursor, so you can start typing code. The gray box is called Input Field. Now, you are in edit mode. The green cell border and the little pencil in the top right corner indicate that as well. To close edit mode, you have to press the Escape button. As I press Escape, I'll go back to command mode, which will allow me to edit the notebook as a whole. This is why the cursor and the pencil disappeared. The cell border turned back to gray and its left margin is blue. Now, I'll press Enter again. I will put a short code that says X is a list composed of 4 numbers, 1, 2, 3, and 4. After that, I can ask the computer to print this list for me by typing X. I can execute these commands in 2 ways. The first one is to hold Control and then press Enter. By doing this, the machine will execute the code in the cell, and I will stay there, meaning I will not have created or selected another cell. Observe that an output field with the same number as the input field appeared. Input and output fields of the same number are grouped together. The output represents the machine's response to your commands provided in the corresponding input, and the respective field cannot be modified. The second option allows for a more fluid code writing. To execute the same code, hold Shift and then press Enter. The previous 2 commands are being executed, and then a new cell where you can write code is created. If you use Shift and Enter, you can continue typing code easily. It is amusing that you can cut, copy, and paste cells. You can use the buttons on the main menu. Since we are keen supporters of ergonomics, we suggest you get used to the keyboard shortcuts. When coding, you will mainly have to use the keyboard, so it's worth memorizing different keyboard combinations that would allow you to work faster. Let's see how we can apply shortcuts in practice. I will cut this cell by selecting it, and then pressing the X key. Remember, you can always use the arrow keys to navigate along your notebook file. So, I will move up and then directly press the V key to paste it. Voila! My cell has moved up here, below the cell I had selected before I pressed the V key. Now, I will press C to copy the same cell. I will use the arrow keys again to go down this time, and at the end, I will press V again. Apparently, this cell was copied and pasted below. In the menu cannot be substituted by keyboard shortcut combinations. They allow you to move a selected cell up or down, just as I am doing right now. Observe that the corresponding output field moves along with its input cell. Lovely! Instead of carrying out a command with Shift and Enter, you might prefer clicking on this button with the mouse. The result will be the same. What is interesting is that when you work with more complex code that requires tougher calculations from the computer, while running the code, a little star will appear over here. Sometimes, this process might take too long to complete. So, to stop it or break it, this classical stop symbol can do that for you. 3 other shortcuts could accelerate your coding a lot. Suppose I have selected this cell. After I press the A key, a new empty cell will be inserted above. If I select the same cell and press B, another cell will be created just below. Imagine the last step was a mistake, and I need to delete that empty cell. In this case, it has already been selected, so I can press the D key twice, and it will readily disappear. Wonderful! All the cells we saw so far were code cells. Let's see what is a markdown cell. It is a cell that contains strictly documentation, text not executed as a code. It will contain some message you would like to leave to the reader of the file. To convert a selected cell into a markdown cell, you should either expand this list and opt for Markdown, or simply press the M button. Press Enter to access the cell and type some text. When I run this cell, the output will be a simple statement. Now, if you want to turn a Markdown cell back to a code cell, select it and opt for Code from this drop-down menu, or press the Y key. To conclude, there are two advantages of using Jupyter. First, when your code becomes longer, Markdown cells turn out to be useful, as they allow you to leave comments and explain the solution you've created. This is why practitioners love to use them. The other benefit of using this app is you can select and execute whichever cell you want to. You need not run all the previous cells to run a particular cell. This allows for solving a problem in pieces and saves a lot of computation time.
This was a long but indispensable lesson. In the next one, we will continue with the exploration of some additional Jupyter tools. Thank you for watching.
This is a video in which we will share two specific Jupyter functionalities with you. If you have worked on a file and have closed it after having run its code cells, the next time you open it, you will not see the code in the input cells only. You will see also the obtained results stored in the output fields. Now, imagine you would like to run the cells from the very beginning. What should you do? The best way to do that is to expand the kernel option from the Jupyter menu and select the option Restart and Clear Output. After you click on it, you must confirm by pressing the Restart and Clear All Outputs button. Then, we will see the only thing left in the notebook file is the code. None of these cells have been executed. That's why there is no number associated with the input cells. So, after we execute the first cell, it will have the number 1. The next one will be numbered as 2, and so on. Great! The other interesting option would be to select Restart and Run All after expanding the kernel option from the Jupyter menu. It will basically proceed similarly to the option we just saw. This time, however, Python will run all code cells from the first to the last, unless it encounters an error somewhere on the way. In case some cells contain an error, Python will simply stop there. In our case, there were no mistakes in the code, and the cells were set in the correct order, so everything will run from the beginning until the end. Is that correct? Yes, lovely. These options can be applied anytime you must redo what you have done with the notebook file. This usually happens after spending a long time on a document when you want to verify your code can run smoothly from the beginning to its end. We hope you enjoyed this video. Thank you for watching.
Okay, so in this lesson, we'll do a quick tour of the Jupyter dashboard, or simply the Jupyter Notebook app. Before you do that, please remember that like any other popular application, this one is occasionally being improved too. Therefore, save for some minor changes, the version of Jupyter we use in this video will act as an accurate and precise guide for using this tool.
As soon as you load the notebook, the Jupyter dashboard opens. Each file and directory has a checkbox next to it. By clicking and unticking an item, you could manipulate the respective object. That means you can duplicate or shut down a running file. In addition, you can rename and delete folders. The selection menu allows you to select all the files in the console of the same type by expanding this button. For example, you could mark all the folders or all the running files. In addition, you can check this little box that will directly select all the items on the page. The logic regarding the directories management is the same as the one of an operation system. Files can be grouped into folders, and folders can contain other folders. From the Upload button in the top right corner, you can upload a notebook into the directory you are in. The standard Explorer box opens, and when you select a file, you can click on Open, and it will immediately appear in your directory. Finally, you can expand the New button. From the list that falls, you will most likely need to create a new text file, a new folder, or a new notebook file. A notebook file can contain code in any of the languages in your Notebooks section. When you create a new Python notebook file, it will be recorded in the IPython notebook format, .ipynb for brief. Don't fear this other new name, IPython. Think of it as the predecessor of Jupyter. Consider the IPython notebook format as a legacy file format. All right, let's carry out a few operations. I will rename this folder to Exercises. Okay, done. Now, I will create a new IPython notebook file by expanding the New button and selecting one of the two Python formats I have here. Let's use the default Python format. The browser immediately opens a new tab for me. This is the interactive shell we mentioned earlier. Here, you will write your code and see its output. More on that in our next lecture. Thank you for watching. All right, what do you need to know about programming if you are just getting started? We all have to deal with certain tasks in our daily lives. Many we can solve on our own, while others, especially the ones that are more complicated, can be solved with the help of a computer. Assume you have defined a problem that must be solved and you know the steps that must be taken to solve it. Even if you could structure your logic perfectly and type a brilliant solution in English, the computer will not understand it, as it understands zeros and ones only, no other symbols. Similar to a light switch, it recognizes two phases, on and off. To communicate a real-life problem to the computer, you need to create a specific type of text called a source code or a human-readable code that software can read and then process to the computer in zeros and ones. A program is a sequence of instructions that designate how to execute a computation. Therefore, the formal definition of programming is the following: taking a task and writing it down in a programming language that the computer can understand and execute. You need not be a geek or computer scientist to program. Actually, the subject of computer science is not the study of programming. These are different things, and this can confuse beginners. Computer science is about understanding what computers can do. Programming, instead, is the activity of telling computers to do something for us. Think about the world we live in today. There are more than 1,000 programming languages out there, and each language is designed for carrying out specific tasks. So, depending on the sphere to which your problem applies, only some languages can be of good use. For instance, PHP is good for web programming, but is not suitable for programming devices. C++ can definitely help you with the latter, while Python and R are some of the favorite tools of data scientists and people from the finance industry. When you meet an experienced programmer, don't think he can program in all languages out there. Instead, it is likely he can work with one or maybe a few languages, but he has mastered them well. Right, but how does somebody become good at programming? First, programming requires problem-solving skills and involves abstract thinking. You are supposed to understand your task perfectly and then break it down into a sequence of instructions or smaller computational steps that the computer can execute. For example, John is asked by his boss to do the following: create a program that adds 10 to any number his boss inputs with the keyboard. The correct reasoning would be, if x is the unknown provided, we need an output of x plus 10. After you have created these steps, with the help of a programming language, you will type in beautifully organized lines of code. So, the second crucial thing to develop is mechanistic thinking. Unfortunately, computers can only execute what you ask them to do. and they won't understand what you imply by the instructions you have provided. They will simply compute the code without interpreting your output. Fortunately, we can do that though. Humans can understand and interpret code instructions and adjust it whenever necessary. And this is why solid knowledge about the syntax of a programming language and the ability to understand computer code is of paramount importance. It will positively affect your thinking process, allowing you to break down your problem into parts the computer can execute. In the example we provided above, John must think of the following subtasks. First, he must define a function that takes x as an argument and then returns as an output a new variable equal to x plus 10. This is how this problem can be solved. Regardless of the problem you are facing or the programming language you are using, your coding style is crucial. Remember that. Having 3 lines of code is straightforward to understand. However, in practice, you will likely work with hundreds of lines of code that must be sent to other people. If your work is difficult to read, unnecessarily complicated, full of variables as names, conveying no meaning, it will be poorly received by other programmers. Therefore, throughout this course, we will pay attention to the best practices that will help you organize your code. Programming challenges are great as they develop your mechanistic thinking and problem-solving abilities. This involves formulating problems, breaking them down into meaningful steps, and communicating these steps to the computer in an organized way. This will do for now. Thank you for watching. For this course, you must install both Python and Jupyter on your computer. If you have them, you can still complete this lecture, because we will say a few interesting things about Jupyter. So, why isn't there just one software application called Python you can install on your computer that is automatically being updated and that runs everything smoothly? I am sorry to tell you, but it's not the case. We have to deal with reality. First, Python is a programming language. It can allow you to communicate with the computer. To do that, you'll need the help of a specific software or an application. Namely, the Jupyter Notebook app, which is more often called Jupyter, can help us to do that. It is a server-client application that allows you to edit your code through a web browser. Consider the following graph. All units represent different software. On one side, you have several language kernels. These are programs designed to read and execute code in a specific programming language, like Python, R, or Julia. The Jupyter installation always comes with an installed Python kernel, and the other kernels can be installed additionally. On the other side, you have various types of interfaces where you can write code. They represent the clients. An example of such a client is the web browser. The Jupyter server provides the environment where a client is matched with a corresponding language's kernel. In our case, we will focus on Python and a web browser as a client, or as an interactive shell. Your work will be stored on a notebook document, and since we will strictly be using the Python language, it will be called IPython notebook file, with the file format .ipynb. Having said all that, we can explain why Jupyter is used in so many large corporations like Google, Microsoft, and IBM. For its design, it is well suited for demonstrations of programming concepts and training. First, in large corporations, solving a particular task could require coding in a few languages, say Python, R, Julia, or PHP. Instead of installing different interfaces for each language kernel you need, Jupyter allows you to use the same structure of the notebook type of file. Simply, each notebook you create will connect to the language kernel you request. Consider also, this file can be easily stored locally or on a remote server. Therefore, Jupyter facilitates the communication between teams in a corporation tremendously. Second, Jupyter is not a text editor that opens a new window every time you execute a different part of your code, as is the case with some other software applications. In the same file, you can have pure text that can communicate a message to the reader, computer code like Python, and output containing rich text like results, figures, graphs, pictures, and others. This simplifies the process of the workflow immensely, And Jupyter Notebook is increasingly preferred over other software packages. That's why we'll use it too. The next step would be to install Anaconda, a software package that contains both the Python programming language and the Jupyter Notebook app. Thank you for watching.
Hi, and welcome back. When speaking a foreign language, or even our native language, we sometimes make mistakes. While coding, the situation is no different. What's great about programming is that you get notified about your mistake. Python, like any other programming language, will display an error message when you request it to do something it does not understand. Consider the following Jupyter Notebook document. Disregard the syntax we'll use and focus on the operations conceptually. They will be a mix of mathematical and programming requests. To begin, we will execute this cell to specify that we'd like x to be equal to the sum of 5 and 3, that is 8. Then we'd like Python to display the value of x for us by running print x in the following way. In the output field, we see what we expected, the value of 8. This means that we have worked correctly and have abided by Python's syntax. But what happens when we do the opposite and disregard the Python rules? As we request the value of y to be displayed, we obtain an error message. How come? The reasons can be many, but what is sure is that we have asked Jupyter to do something it cannot understand. To solve this problem, Jupyter itself assists us by explaining to the best of its abilities what prevents it from executing the operation from the relevant code cell. Please remember, and this is extremely important, the idea is to use this hint to improve our code so that we obtain the desired output. In this example, we are having a name error. Jupyter is even being specific by telling us it doesn't understand what we mean by y. Here is the moment where you, as a programmer, have to realize what type of an error that is. Considering that the interpreter is reading your code letter by letter and line by line, this means that there was nothing wrong with what we've written until y. So, the error seems to be related to that letter, and the last line of the error message confirms it. Please remember that in the majority of times, the last line of the error message indicates where the problem is coming from. Then, as programmers, we realize we can solve this particular problem in two ways. One would be to provide a value for y. The other is to assume that we have just not referred to the correct variable. Therefore, we can substitute y with x and execute the cell again to obtain a satisfactory output. Great! It doesn't sound hard at all, right? Well, yes, but that's just the beginning. It is important to realize there's no guarantee that you're having a single cause for a problem. For example, if you type print y like this, Jupyter will just indicate that it doesn't understand what the first 4 letters are there for. It will be the job of the coder to remember that the command they need is print, not prit. At the end of the day, you may have just made a typo. However, when you correct this and re-execute the code, you'll receive an error message again. At least, this one looks familiar. You know how to solve it within the boundaries of our example. So, substituting y with x can finally lead to the right outcome. All right. Aside from the technical perspective, there are several takeaways from this lecture. We can't rely on Jupyter to be always telling us the exact reason why it was not able to execute or request at a specific moment. It is amazing how accurate and precise it can be in its suggestions. But don't be surprised. Sometimes the obtained error messages won't be very clear to us, the programmers. Therefore, it will be our job to understand the messages and decide on how to solve the given problem. Then, don't forget that coding is all about using a programming language to solve certain analytical tasks. So, every programmer has encountered countless error messages on their way. What is important is to know how to handle them. Try to understand and resolve them, and don't pretend you're able to write the perfect code from the first try. That is impossible. On that note, please follow this guideline. Don't quit on your task, and be ready to respond to as many errors as you need. Of course, this doesn't mean there's no place to get support from. For instance, you can Google the error. Just paste the last row of an error message online and see if there's a thread or a post that can help you solve the problem yourself. This approach will not be preferred or needed throughout the course, I believe, but will serve you a great deal after completing it, or also as a professional when you will already be an independent programmer. In other words, Googling the error is what you would do on the job, so it is good to get used to it. Regardless of whether this strategy works, you can search for the relevant error in the Q&A forum. Alternatively, if you can't find an answer there or you stumble upon a recurring problem, please do feel free to post a question yourself. We will be happy to reply as soon as we can. Just when you do that, please stick to the following structure. Let us know what your task is and what output you're aiming for. If you can point us to a particular lecture or section from the course, please do that as well. Then paste the exact code you have executed before obtaining an error message. Third, provide a screenshot of the error message, or at least its very last line. That one is very important. Finally, anything else you can share about the problem will be much appreciated. Having this type of information will help us immensely to assist you better. So, we would be extremely grateful if you spend the time to provide it. To conclude, you don't need to just try and execute random code at this stage, but the principles delineated in this lecture will be applicable while programming in Python or other languages throughout the entire course and beyond. This will do for now. Thanks for watching. We'll provide you with some additional information that can further improve your experience while coding in Jupyter. To begin, make sure you're in command mode. That is, check that you have not double-clicked on any particular cell of your document and that you don't see the little pencil on the top right here. Once you confirm this, press the H key on your keyboard. A new window pops up. It contains information about the two modes you are aware of, the command and edit modes. Their description has been displayed on top. Below, there is a list with all keyboard shortcuts currently available in Jupyter. You can always refer to that list while coding, because in your practice, you will increasingly need more functionalities. The best way to take advantage of this feature is to check the desired shortcut, and then close the Keyboard Shortcuts window before applying the functionality in question. To achieve this, you can either press the Escape button on your keyboard if you haven't clicked on the window, or the close sign at the top right of the window. Another option is to hit the Close button at the bottom right, or simply the H key again. Assuming all this is clear, let's press H to open the list once more. For the sake of exercise, let's go through a couple of functionalities that you may benefit from at a later stage. We can scroll down to see that the O button can be used to toggle output of selected cells. What does that mean? Press H to close the window, and then make sure you've selected the only cell we have in our document. For the moment, you don't need to concentrate on its contents. That said, the cell contains a comment and 2 lines of code, one indicating that the value of a variable x will equal 3 plus 5. And another printing the value of x. Press Ctrl and Enter to execute this code, and you'll obtain the value 8 as an output. Great! Now, if you press O, the output will hide or unhide. Of course, you can achieve the same by double-clicking on the gray box that appears here, then single-clicking to bring us back to the previous state. If you wonder why we are showing you this particular shortcut, please consider that in this example, the output doesn't take much visual space from our document. However, when we get to work with output fields containing entire data tables, this functionality will come in handy. The other shortcut I wanted to talk about was using the L key. Press H to see that you can use it to toggle line numbers. Close the Keyboard Shortcuts window and then select the cell again. Press the L key now. What happened is that line numbers appeared to the left of every row. Once more, the number of each row of code here seems to be obvious. But when your code is getting longer, using the line numbers will be of great help to fixing your code with your colleagues. These were the 3 shortcuts I wanted to share with you at this stage. Naturally, you can feel free to come back to the H list, so to speak, and explore more of the provided shortcuts. See you in the next lecture. There are various ways to install Python on your computer, but if you are a new Python user, it is highly recommended to install Anaconda. Anaconda will not only install Python, but also the Jupyter Notebook app, as well as many packages for scientific computing and data science. Please keep in mind that, just as any other online service, Anaconda are constantly updating their products and websites. So, even if their interface or organization looks slightly different when you access their web page, the functionalities are likely to remain the same. That said, let's open www.anaconda.com and click on the Get Started button on the homepage. Then we need to indicate that we want to install the Anaconda Individual Edition. At this stage, you are welcome to read some introductory notes about Anaconda, but now we will just click on the Download button. Doing so will lead us to the bottom of the page, where you must pick one of the 3 operating systems, Windows, Mac, or Linux. In this lesson, I will show you how to install Anaconda on Windows, but the procedure is identical for Mac or Linux. Other than that, I am sure you noticed that under each operating system, it says Python 3.8. This is just the current version of Python, at least at the moment of recording this video. If in your case it is not, please make sure you select the latest version available. Then you must choose one of the 2 provided options. Which version do you need to install, a 32-bit or a 64-bit version? This will depend on the Windows version you are running. So when you choose between a 32 or a 64-bit version, you can simply check your operating system. Newer computers are most likely running with 64-bit processors, but if you want to verify this before you begin, you could easily do that. First, open your control panel menu from the Start window. Then select System and check the information referring to the system type. In my case, it is 64-bit. So when I go back to the Anaconda website, I will select the 64-bit version. Then you must find a directory where to install the distribution and press Save. When the download is finished, run the application. What follows is nothing different from the standard Windows installer. Agree and press Next until you have the chance to designate a default or specified destination folder. If you want to opt for the latter, you can click on the Browse button. When satisfied with the indicated directory, click Next one more time. Then follow the suggestions made by the installer. For instance, I will take the second option only. Finally, click Install and wait until you've been told the operation is complete. That's basically all we needed to install. So I'll skip and untick any suggestions I see from this moment on, and will then click on Finish. What you just installed is the whole Anaconda distribution, the Python language, a text editor, many applications, and packages. You also have the Jupyter Notebook app. You can open the Start menu and select the respective icon from there. A new window will pop up. It will take a few seconds for the app to load. Once this is done, your web browser will open a new tab with the Jupyter dashboard. Bear in mind that there's an alternative for starting Jupyter. You can open the Anaconda Navigator app, which will lead you to install software tools that come with the Anaconda distribution. We are focused on Jupyter only, so if I click on the relevant Launch button, I will once again open a new tab in my web browser. In our next video, we'll study the dashboard in more detail and learn how to use Jupyter. See you there! Thank you for watching. As an analyst, if you want to use a programming language to work on a given dataset, don't think that your colleagues will be chasing you with a laptop and begging you to code. On the contrary, you will be expected to know what coding is about and set up a programming environment yourself. To be honest, if you already have some experience with programming and have set up a software you can use Python on, you might not need to go through the lectures from this section. However, a 5-minute refresher on the concept of programming wouldn't hurt. Besides, please consider that throughout the entire course, we will code in Jupyter. So, to ensure that you will cover all lectures smoothly, we do suggest you use the same tool to complete the program. To respond to this idea, we will explain what programming is about in the next lecture. In the several remaining ones, we will talk about Jupyter, install it, show you how to use it, and we'll share a couple of shortcuts as well. Then, we will discuss 2 very important techniques. The first one concerns what to do when you obtain an error message in the process of coding. The second one aims at clarifying how to start with a clean slate if at some point in your work you feel stuck. To summarize, the purpose of this section is to ensure that before you focus on coding in Python, you will be able to work independently in the relevant environment. In our case, this will be Jupyter.